My name is Allison Baker and I'm a third-year undergraduate at Ohio State. The research that I'm presenting today is being conducted as a part of my undergraduate honors thesis entitled An Investigation of Visual Memory and Language Development in Children with Autism Spectrum Disorders. This work is being completed through the Autism and Child Language Lab under the mentorship of Dr. Allison Bean Elevati. Expressive and receptive language impairments are often reported in children with autism spectrum disorders. However, the cause of these impairments still remains unknown. This research seeks to investigate one of the most underlying mechanisms to language acquisition and visual memory. Visual memory is the ability to retain a mental picture of an object once a child has been familiarized to it. Consider word learning, which requires the pairing of both an auditory stimuli as well as a visual stimuli to create a word-referent pairing. Take, for example, pairing the word apple with the image of an apple. Thus, when the child is presented with an apple, they will remember that they already have acquired that word-referent pairing and be able to attend to other stimuli, such as an orange. Previous studies on visual memory in children with autism spectrum disorders have focused mainly on social stimuli, particularly facial recognition. These studies have been very few, as well as yielded very mixed results, ranging from children with autism display atypical eye gaze to attend to different parts of the face to overall have varying levels of attention. To date, only one study has investigated visual memory as a function of non-social stimuli, and that is Courtney Vanker's 2013 doctoral research dissertation, which concluded that children with autism did not display visual memory impairments. We believe that the lack of difference can be attributed to the experimental design, and we have modified that experimental design to be more analogous to real-world language learning. This research seeks to address three main questions. First, do children with autism display poorer visual memory than their typically developing peers? Is inattention associated with poorer visual memory test performance? And lastly, does stimuli complexity impact visual memory? To date, we've had 12 children participate in the study, divided into three groups. The first being the group of children with autism, the mean age of 4 years, 6 months, and a visual receptive raw score of 35.5. This score is intended to serve as a representation of nonverbal IQ. Then we have the typically developing visual receptive matched groups, which have an overall average age of 2.2 and a visual receptive raw score of 33.67. Lastly, we have the typically developing age matched group, which age-wise is 4 years and 1 month, however have a considerably higher visual receptive raw score of 44. When the children came into the lab to participate in the study, they were seated in a soundproof booth, and their face was recorded using a video camera. The child viewed 2 videos with 6 trials of the visual paired comparison task. One trial of the VPC task began with a 1-second black screen, followed by a 5-second familiarization phase, in which the child was presented with the same blue shape against a gray background on both corners of the screen. It was then followed by a 1-second black screen, again then followed by a 3-second test phase in which that familiarized shape was put into conflict with a novel shape. Attention to the novel shape indicates that the child has retained the mental image of the familiarized shape and thus displays visual memory. Lastly, the children then saw a 1-second black screen. Again, the child saw 12 total of these trials. Every 2 were separated by a 5-second attention-getting video. These shapes that were presented were scored by volunteers in the Autism and Child Language Lab. Shapes that scored high were considered complex, and shapes that scored low were considered simple. Then these shapes, either simple or complex, were put into conflict with shapes scored as average. Children also received the Mullen scales of early learning, as well as children with the diagnosis of autism also received the ADOS to confirm their diagnosis. The video that was recorded was then extracted and coded using iCoder. The child's eye gaze was coded as either right, left, or away during both the familiarization and test phases. The data that was extracted from this coding has indicated that children across all three groups displayed similar levels of attention during familiarization. The children displayed between 35 and 39% inattention during this 5-second familiarization phase, thus indicative that the children were attending to the screen the majority of the familiarization time. However, we begin to see differences when examining the visual memory at test. First, we have the gray bars indicating the complex shapes, then we have the black bars indicating simple shapes, and lastly, red showing the overall average for each group. In the children with autism, we see that overall their rates were at or below 50%, indicative of attention at chance. Additionally, these children performed better on simple shapes than complex shapes. The typically developing visual receptive matches appeared very similar to the group of children with autism. However, they did perform just slightly better, but again, still around 50%. And then lastly, we have the typically developing age match peers who performed significantly better than both of the other groups, well over 50%, indicating stronger visual memory skills. Additionally, the children who were age matched peers attended more or displayed stronger visual memory skills on the complex shapes, and we attribute this to the fact that they were increasingly interested in these complex shapes, and these shapes were able to hold their attention. The typically developing visual receptive mates performed very similar to their peers with autism, both performing better on the simple stimuli than the complex stimuli. Overall, the children with autism did perform worse than their typically developing age match peers, as well as we saw differences in visual memory skills across the shape complexities. Because the children displayed similar levels of attention during the familiarization phase, it can be concluded that the observed differences in the level of visual memory indicate that the level of focus needed is a function of the cognitive development. This can be attributed to the fact that the ASD group and their typically developing visual receptive mates differed in age by over 2 years. Limitations of this study include overall low levels of attention from all of the children, as well as individual variation across the groups, and particularly in the group of children with autism, as well as further more in detailed examination of what actually qualifies as a fixation to either shape. In the future, we plan to continue data collection on the present study, thus allowing us to further investigate individual differences in the groups, particularly, again, that group of children with autism. Additionally, we plan to look at these findings in relation to the findings of another study investigating the shape bias that is currently taking place in our lab. It is our hypothesis that a lack of visual memory will be connected to a lack of the shape bias, thus preventing children with autism from being able to utilize the shape bias to facilitate their language acquisition.